All right, ladies and gentlemen, welcome to another one and done. This is a great problem, okay? A great problem because what's happening in here is that you got scale measurements. They're talking about two-dimensional cross sections. You're talking about area of multiple shapes. Goodness gracious, they got all different types of things going on. So let's talk about how you go about to solve a problem like this with so many components or so many parts. This question is not difficult, but you got to make sure you organize everything together, all right? First and foremost, anytime you have a scale, you need to convert your numbers before you do anything else. Please remember that. My scale says that I have 1 centimeter to every 3 inches, okay? So now all of my values up here are in centimeters. Centimeters, 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 centimeters. So what I want to do is I want to take the number of centimeters because 1 centimeter equals 3 inches and multiply all the centimeter values by 3. So what happens is when I do this, this becomes 6 inches. This one right here, remember, these are all inches. This one right here becomes 3 inches. This one here becomes 9 inches. And last but not least, this one becomes 12 inches. All right. These guys are no longer, we're not even going to use them. We're going to use 6, 3, 9, and 12. All right. So that is the first thing you ever have to do in a geometry problem that requires you to use scale measurement. Okay. Secondly, what the heck is this? Two-dimensional cross section. And when I read this question, it's telling me that the part is cut in half through the vertical axis. So what that means is you are making a vertical cut. You are taking the shape and you are cutting it in half, going from top to bottom. Remember, there are 3 types of cuts in geometry. You got vertical cuts, you got horizontal cuts, and you got diagonal cuts. This one, we are cutting vertically. So that means we are taking a blade and we are slicing it right across there and straight down. All right, straight down. Now, what happens is when you cut that thing straight down, when they talk about a cross section, this is what they're referring to. When you cut that in half and you pull it apart, you are looking at the core. You are looking at the inside, okay? Because when you pull it apart, the inside of both shapes will be exactly the same. What are they going to look like? They're going to look like this. When you cut cylinders in half vertically, what you're looking at is you're looking at rectangles, all right? This is what the inside is going to look like of that shape when you pull them apart. And what happens is now the rectangle at the top here, you got the 6 by 3, and the big rectangle down here, you got the 12 by 9. So when you go through and you calculate each of your cross sections here, this guy is going to be 18, 6 times 3. And when you multiply 12 times 9, you end up getting 108 for this section. And all you got to do is combine those two together, and you get a total area of your cross section. The hardest part for students when they do a cross-section question is to visualize, because you don't have it in your hands. You're not actually cutting. They're just describing it to you. You need to visualize what is the shape that is formed in the inside when you cut or do something along the lines like that. That's the toughest part. And then once you have that, everything else becomes a piece of cake. So this is an example of both scale and cross-section and how they're applied. Any questions, let me know. Hope you find this both helpful and informative.